Okay, welcome everyone to another day of applied math. I'm going to continue on with assignment 3. I had left you entering it into our calculator and converting that into a I realize that some people from emails are just hopping onto the site now after a long break. So it's following along when I started live streaming. But you'll have a bit of catching up to do. But that being said, I think I'm going to take it slow. I'd rather take it slow and make sure that people maybe can catch up with us, especially with the technology. Fortunately, school was suspended just as we were learning how to use our graphing calculator. And I mentioned before classes ended to please come and see me and get the technology you needed to keep going on with the course. Many of you did. Some of you, I'm fearful, didn't. So I'm not sure how that's going to work out for you. What I'm doing now is I'm just going to go through assignment 3. So if you finished assignment 3 and you had no problems, I guess you could take the day off and maybe catch up on some of your other schoolwork, because I'm going to go through the questions for assignment 3 for the benefit of students who are struggling a little bit with the graphing calculator portion. I was emailing with one of the students in our class that he was having troubles getting his Android phone converted to a graphing calculator, but I emailed the ROM to him and now it's working. So if you are experiencing problems with the technology, please let me know, because I can't help you if I don't know that you're having problems. I'm assuming that everyone who's using either the flash drive and you loaded it up onto your computer, or you're using your phone as a graphing calculator. So either one of those is great. It's probably a little easier maybe to use your phone. Otherwise, you have to use your mouse. I'm just not sure. But if I don't hear from anyone, I'm assuming everyone's working their way and using the graphing calculator, because that's the application I'm going to be using unless I hear otherwise. So I'm going to turn my calculator on and I'm going to clear it. Like I told, I'm just going to raise this just a little bit so you can see a little bit more of what I'm doing. Okay, I'm going to clear my calculator. Second plus sign, number 7, number 1, number 2. So clears everything, and that makes me aware that there's no data left over from Friday. Okay, just going to see if I can do this bit. So now I'm going to tackle question number 1. It says determine the regression equation for the data shown. All the steps have been shown in previous classes, but I guess just as a quick thing, I'm going to enter my data using stat edit. Okay, so that's the first thing I'm going to do. Just going to clean my screen off a little bit here. Okay, so I'm going to go into, see if you can, okay, I'm trying to make this as good as possible for you. Stat to lists. This is all the data I'm going to put in list 1. So this goes in list 1, and these are my X values. This is data that goes in X2, and these are my Y values. Okay, so 82,100, enter. 59,600, enter. 57,800, enter. 25,700, enter. 24,400, enter. Now I'm going to cursor over with my arrow and enter the second list in. 406, 229, 281, 64, 18. Okay. So that's the first step that I'm going to do. Okay. So that's my first thing that I'm going to do. Number 2. I usually turn my stat plot on. Turn stat plot on. Again, you can refer to previous page notes or previous video, but I just do second one equals and I turn it on. And change windows. Okay. Now that's a big deal, right? When I press window, if you put your calculator up, you know that the default settings for the TI-84 are just 10s, like a high of 10, a low of -10 on both axes. I can see my data is way bigger than 10s. So what I'm going to do is I'm just going to quickly identify, here's my lowest value, right? This is my lowest value. This is the smallest, the minimum value, and this is the maximum. So for the X min, I always go a little lower than the min and I go a little higher than the max. I think maybe I'll do for X min, I'm going to do 20,000. And for X max, I think I'll do 100,000. And then my Y min, the lowest Y value is this one, min, and the highest one is this one. It doesn't always go like the top and the bottom marks, by the way. It's just, you always have to check the data. So my Y min and my Y max, what will I use here? I think I might go 0. And maybe I'll go, I don't know, 450. Okay. So this is probably what, after you enter your data in, reflect the data given. So X min 20,000. X max 100,000. And then, whoops, sorry. I did that backwards, didn't I? Oops. This is a big problem. The smallest value I want is 0, and the highest value I want is 450, okay? So that's going to be a 0, and that's going to be a 450. Okay, let's see. And sure enough, I have my data. I should see 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. So you can see that this is, again, a linear pattern, right? It's a pattern kind of moving up. I read my graph from left to right, and from left to right, it's trending up. Okay, the next thing I do is I get the equation, right? Now, this is all detailed on page 13. So I'm going to say, get the regression equation. Page 13. Okay, so there I do stat and I press calc. And I want, it's linear, it's a line that's forming. So I press number 4. And I move down to store reg. And this is where I have to stop. I press vars, y vars, and enter. And I want it pasted in y1, so yes. And then I just move down to calculate. And that does two things. It gives me my equation, right? It actually doesn't give me the equation, but it gives me the info I need to make the equation. This is my A value, this is my B value, and I have to substitute those into this equation here. Now, because this is such a small A value, I think I'm going to go to 3 decimals, to be honest, this time. I don't normally do that, but I'm going to say y equals 0.006, just because I have 2 zeros here, so I'm going to use 3 decimals this time. X plus minus, well, the minus will supersede the plus, 0.646. I'll use 3 decimals here as well, okay? So this is my regression equation. Use the regression equation to predict the depth that has an area of 43,000. Okay, so basically they're asking me to find y, right? That's what they're asking me to do. Find y when x equals 43,000. Again, we learned this on the examples. So here I go second and then I press trace. And then I press number 1, value, enter. And I get x equals, and they want me to know, they want to know what x I want it to be. Well, I want x to be 43,000. So then that tells me when X is 43,000, Y is this. Y equals 155.48. And that's the depth, right? The depth will be okay. So let's kind of get you to look there. Once you do a few of these, it just becomes repetitive, right? It's getting the steps, like the steps won't change at all. So that's what I'm going to do today. So if you've kind of mastered all this, it might be quite repetitive for you, but I'm going to do all 5 questions. So there's absolutely no possibility that if someone watches the video that they won't know how to do this. You need either the graphing calculator on your phone, if you have an Android phone, or you need that calculator app that I made available to people so you can use it on your computer. So please let me know. Through email or like how you're doing if you're struggling with this a bit. All right, determine the regression equation for this data shown. All right, so I'm going to clear my calculator out. Clear. All right, I have a new set of data to type in, right? Stat, edit. Got to type all this in. This is my X, this is my Y. Okay. Okay, so I typed all my data in. I'm going to turn my stat plot on just so I can see my data. And I'm going to adjust my windows. Let's see. I'm going to say X-min, X-max. Let's see. This is my smallest value for X. Looks like it's going to be 1, right? And my largest is 5.3. So I think X-min, I'll say 0 and 6. And then Y-min, Y-max. Let's see, Y-min, my smallest is, let's see, looks like it's 4.3, right? And my largest is 12. Okay, so Y-min, I'm going to say 0. And how about 15? Right, this is very important. So I go to my windows, 0 and 6, 0 and 15. Okay, now let's take a look at the graph. I should see how many, 1, 2, 3, 4, 5, 6, 7, 8 dots. 1, 2, 3, 4, 5, 6, 7, and I think some are mushed up here. So it looks like my data is represented. Sometimes you can't see all the dots if they kind of are sitting on top of one another. So now I'm ready to do the page 13 stuff. I have to get the regression equation, right? That's what it's asking me here. Determine the regression equation. Okay. So stat calc number 4, move down, and this is where I press my bars, Y bars, yes, yes, yes. So here's my regression equation. I have to substitute the A and the B in the appropriate spot. So Y equals 1.29x plus 3.63. Remember, your default for applied math is 2 decimal digits. Okay, now we're just recording the rounded equation. The real equation stays here. And when you did that, when you did this part, the vars, Y bars, you were actually pasting it into the Y equals screen right here. And that vars, Y bars thing, that page 13 stuff does 2 things. it pastes it into the y equals, but it also creates a line. This is the line I'm interested in, right? This is the equation, the regression equation, this line. Okay, so now it says, and it looks like there's a positive correlation, right? Describe any trends or relations. Going back to our previous lesson, it's a positive correlation. So in this circumstance, a positive correlation means, let's see, the higher the engine size, the more fuel used. The higher the engine size, the more fuel is used. Okay, use the equation. So that means use the info I have in my calculator to predict the fuel of a 4-liter engine. Let's see, a liter size is X, so find Y, right? Y stands for fuel use. When find Y, so stat edit, I put all my data in. Okay, now hopefully you know the drill. I'm going to turn my stat plot on. I'm going to change my windows. So let's see, I'm going to say X min is 0, X max. Let's see, the largest number I have is 4. So I'm just going to take a quick look. Yeah, I think maybe I'm going to put 6. Okay, because I kind of looked ahead and I saw they want me after 5 seconds. So it has to be greater than 5. So I'm going to put a 6 there. I'm getting smarter, right, as we work through this. I'm starting to learn a bit more about max mins. I'm going to look ahead at the question a little bit to make my job easier so I don't get error messages. Let's see, the smallest is 1.2, so I'm going to put 0. The largest is 23.6, right? So I'm going to put, I don't know, 28. As long as it's bigger than 23.6, you should be okay, but I always go a little higher, like I said, okay? So 0 and 6, and 0 and 28. Okay, now when I press graph, I should see my points. Oh, I just realized something. This is not a straight line. So sorry about that, guys. We are not doing this one. Oops, sorry. I'm going to omit this one for now. This will come in the next unit. Sorry about that, guys. You can see the reason I'm omitting it, we are going to cover this. This is called a parabola, but it is not it's not linear, right? A linear would just go straight up. This goes up and then comes down. So we'll leave this and we'll come back to this in the next chapter. I don't want to confuse things right now. This should have been taken out. All right, we're going to move on to the next one. Sorry about that. So I got to clear this out. Second plus sign number 7, number 1, number 2, cleared. Okay. I thought we took out all of those, but I guess we left one in accidentally. Let's see. So determine the regression and then 65 hours. Okay. So stat edit. Okay, move over to the second column.
These came back from a search.
Okay, so I got my data in. I'm going to turn my stat plot on. And then I want to change my windows, right? X min, X max, Y min, Y max. Okay, so let's see. X min, my lowest number is 12, but it's not that far from 0, so I'm going to start at 0. So this is my lowest number and my highest number is 62. I was looking ahead at the question though, and it said 65. They want us to use a 65. So I'm going to go for my y min, I'm going to put 0, right? Because this is my lowest. This is my highest. So I'm going to put, I don't know, I'll put a 25. Okay. So changing the windows is super important. So 0, 70, 0, 25. All right, let's see if I can see all my data. 2, 4, 6, 7. 1, 2, 3, 4, 5, 6, 7. I see all my dots. So I see a linear pattern again, but this time for the first time, it's descending line, right? Descending, going down. So determine the regression equation. All right. Stat calc, number 4. Move down to the store reg, vars, y vars, equal, enter, and calculate. So here's my regression equation. Y equals negative 0.31. Now I'm rounding for the paper, right? But your calculator actually keeps all the decimal numbers, which is the greatest thing about using technology, right? It doesn't round, it keeps all the decimals. I, of course, have to round, otherwise I wouldn't be able to write something down on the paper, right? And you wouldn't either. We're rounding just for the, just to get something recorded on the piece of paper. So our regression equation is negative 0.31x plus 21.27. And what that does is that represents the equation of the line of best fit. So the line of best fit is a line running through the points and trying to touch as many of the points as possible. So there's my line. And once I have that line in, I can answer any other question about the data. So now it says, use the regression equation to predict the golf handicap for a player that practices for 65 hours. Well, 65 wasn't one of the numbers on my list, right? But because I have this line entered in my calculator now, basically, it's asking me to find y when x equals 65, okay? Because 65 is not one of my data points. But the line, because I have the line entered in, it's going to give me the value I'm looking for. So I go second trace, and I'm going to choose value. And it's going to ask me what I want x to be, and I want x to be 65. Y equals, right down here, 1.16. Okay, so that kind of fits with the data, right, I think. So the handicap, the golf handicap is 1.16 when 65 hours are practiced. Okay. So see how this becomes very repetitive. Some of the things, like the windows for each question will change because your data changes for each question. Your windows change, your data changes. Obviously, your equation changes because it's based on the data. If the data changes, the equation changes. But as for how to enter the data, find the equation, and then solve for these, that's all the same from question to question, right? So let's try this next one. I think this is the last question, and then I will leave you for today to kind of review this stuff before we move on to tomorrow's stuff. So I'm going to clear my second plus sign, number 7, number 1, number 2, clear everything. I'm going to enter my data in. Okay, turn my scatter plot on. change the windows. So I think I want to make my X min, X max. So these are years, right? This is my X column, my Y column. So I think maybe I'll start at 1945. And let me just move ahead. Oh my goodness. 2000. So let's make my X max, I don't know, 2010, just to make sure it goes higher than 2000. Y min and Y max. Let's see, car sales, let's go 300 to, I don't know, let's say 1,000, let's say 1,500. Now these are in thousands of dollars, right? So you have to keep, so, and the reason that sometimes they'll adjust the numbers in the table because they don't want you to have to type in so many zeros. So just remember, this is actually car sales of 325,000 or 100,000, right? You're going to basically multiply this by 1,000. So that's 325,000. Okay, so I'm going to change my window, 100,000, but it'll go in as a 300. So remember, this is 1,500,000, which is 1,500,000. Okay, let's try this. So here I have this data going upward, right? Sketch the scatter plot of the data shown. Okay, so remember what scatter plots need? They need a title. So this is year, and this is car sales. Car sales in thousands of dollars. And this is dollars, and this is a year. So I have to use a ruler to make sure that I'm doing things properly proportioned, right? So let's see, my first year is going to be, my minimum was, so I'm not starting at 0 this time, right? I'm starting at 1945. I'm going to go up to, let's see, I'm going to have to go up a lot, right? Let's see, I have to go up by 55, 65 years. So 20, 40, 60, so 65, 85, 2005. Maybe I'll go up by 25 years. 1945. So I'm going to go up. I'll have to follow the proper rules of graphing. Now for hundreds of thousands, so I'm going to do this on the, like I don't have to start at 0 here, but I have to indicate I'm not starting at 0 here. Right? 3, 6, 9, 12. So let's do 300,000, 600,000, 900,000, 1,200,000, 3, 6, 9, 12, 15. So that should work, right? Okay, so I'm just doing, now I can kind of copy this data here. Or I can just kind of use my, right? So 1950 is going to be about, and 325 is about right here. At this point, I'm kind of just a little more. 1960 and 448, another little cluster here. 1965, oops, about here. 1970, 640. 1975, relationships between year and car, there's a positive correlation. That's what type of correlation it is. So see that word relation in relationship, correlation. So what this means in this question is as the years progress, car sales go up, right? As years go by, as time moves on, car sales increase. Okay? Determine the regression equation for the data. Okay, so just like before, now we got to get the equation. Stat calc number 4. Stop here. Press bars. Y bars. Enter, enter, move down, enter. So this gives me my A and B value, which I have to substitute into my equation, the form of my equation. So y equals 24.8x plus minus, the minus will overpower the plus, 4087. Okay. Use the equation to predict the car sales in the year 2000. Okay, so find y when x equals 2000, right? Because x is my year, y is my car sales. All right. So I'm going to just press my graph again. So now I see this nice straight line. That means I can answer other questions. So second trace value, they want to know what x is. Well, x is 2000. So y will be 1513. Y equals 1513, right? But remember that car sales are in terms of thousands of dollars. So 2000 car sales will be, okay, so it's 1513 times 1,000, right? So what that gives me is 1513 times $1,000, okay? 1,513,000. So all you do is add your 3 zeros at the end, right? Okay. Now this is a big deal in applied, right? Because our data is great. We did everything properly. We got the right equation. We got the right prediction. But again, remember that this is a prediction. It's not 100% certain that it will happen. What assumption are we making? Well, the big assumption is we are assuming that sales will continue to increase. Oops. At the same rate. And that might not always be true, right? They might not increase at the same time. They might actually increase faster or slower. I think in recent years, we're finding a little bit of a decline, right? As people maybe move more towards mass transportation or public transportation due to global warming. However, in the recent pandemic, people might be going back to wanting their own vehicles. So it's a very interesting time. This was just a prediction based on the year 2000. That already was quite a long time ago. So a prediction is just that. We can't say for certain what will happen or what did happen, but we're making a prediction based on the data given to us. So based on the data given to us, this is the amount of sales that we would expect. Now, that was a lot of video watching on your part. So I'm going to give you today to kind of review this. Let me know how you're doing with your graphing calculator. If I can help you out at all with that. And tomorrow I want to start actually exploring linear functions a little bit more. And we're going to come at them from a different angle tomorrow. We're going to be given the linear equation. You know how we were, when we have an equation in this form, the y equals form, this is a linear equation. But here we developed the linear equation on our own from data. Tomorrow, I'm going to give you the equation and we're going to explore the linear function from a given equation. Okay. So there was no chatting today online, no questions asked, but maybe you'll have something over email. I am going to end the stream now and I will see you tomorrow. Hey, hi. Okay, so I'm just looking at example 8. Is that the one? Okay. Yeah.